The universe has long been thought to have originated from an infinitely dense mass of matter that underwent a sudden explosion, the Big Bang, giving rise to atoms, molecules, stars, and galaxies. For decades, this has been the dominant explanation among physicists. However, recent research challenges this notion, suggesting that the universe may not have had a single starting point but could instead be part of an eternal cycle of expansion and contraction. If true, this would mean that the universe is caught in an infinite loop of rebirth, fundamentally reshaping our understanding of cosmic history. Renowned physicist Brian Cox has also raised doubts about the traditional Big Bang theory, questioning whether something can truly emerge from nothing. This skepticism is echoed by new observations from the James Webb Space Telescope, which have uncovered anomalies that cast doubt on the idea of the Big Bang as the absolute beginning. If the Big Bang was not the true origin of everything, then what came before it? In this exploration of the cosmos, we will delve into the latest theories challenging the Big Bang and uncover what might lie beyond the boundaries of our current understanding. Scientists have constructed a detailed model of the universe's early moments, known as the Big Bang theory. According to this framework, around 13.8 billion years ago, the universe was an incredibly hot and dense point, smaller than a peach yet containing everything we see today. In mere minutes, fundamental elements formed, eventually giving rise to stars and galaxies. The theory has withstood rigorous scrutiny, with evidence such as the cosmic microwave background radiation, and the distribution of light elements aligning with its predictions. Yet, despite its success, the Big Bang theory remains incomplete. The greatest mystery lies in the universe's first moments, an era where existing physics reaches its limits. General relativity and high-energy particle physics provide useful tools for understanding the cosmos, but as we push further back in time, our equations break down. The most glaring issue is the singularity at the heart of the Big Bang, a theoretical state of infinite density and temperature. This concept seems physically absurd and suggests that our understanding is missing a crucial piece. Addressing this puzzle requires new physics, particularly a theory that unites gravity with the other fundamental forces at extreme energies. One of the most promising candidates for this unification is string theory. Within this framework emerges the concept of the ekpyrotic universe, derived from the Greek word meaning conflagration or fire. This idea proposes that the Big Bang was not a singular beginning but rather the result of an earlier cosmic event. Building upon this notion, cyclic cosmology suggests that the universe undergoes endless cycles of expansion and contraction. Though variations of this idea have existed for centuries, string theory provides a mathematical foundation for it. In this model, each universe follows another in an eternal sequence, with each collapse giving rise to the next Big Bang. Nobel Prize-winning physicist Roger Penrose has proposed an even more radical version of this concept. He discovered a remarkable mathematical relationship between the universe's earliest and latest stages. At one extreme, the universe was a tiny, dense, hot state at the Big Bang. At the other, it will be an enormous, cold, nearly empty expanse in the far future. Astonishingly, when taken to their extremes, these two states become mathematically indistinguishable. Penrose suggests that the vast, empty universe of the distant future could transition into the compressed state of a new Big Bang, creating a cycle of endless cosmic rebirths. This idea hinges on an advanced mathematical transformation known as conformal mapping, which alters an object's scale while preserving its fundamental shape. In essence, Penrose argues that under extreme conditions, size itself becomes irrelevant. What appears to be a cold, empty void from one perspective may, from another, be the birthplace of a new universe. If cyclic cosmology is correct, then our universe is just one of an infinite series, each emerging from the remnants of the previous one. However, this raises a profound question: how did the cycle begin? There are several possibilities. One is that the cycle has no physical cause and simply exists as an unexplainable feature of reality. Another is that each cycle is influenced by the quantum state of the previous one, meaning the universe has been evolving through countless iterations. A third possibility suggests a self-contained loop, where the beginning of each cycle is determined by its end. Penrose's interpretation of quantum mechanics adds another layer to this theory. In quantum physics, a system exists in multiple states until observed, at which point it collapses into a single state. Penrose proposes that similar quantum processes determine variations between each cosmic cycle. If true, faint traces of previous universes might still be detectable in the cosmic microwave background radiation, providing experimental evidence for the theory. The implications of cyclic cosmology are profound. If the universe has no true beginning, then the question of what came before the Big Bang might be meaningless. Instead of a singular creation event, we may be part of an endless cosmic rhythm, where universes are born, live, and die, only to rise again from their own ashes. What do you think? Could the Big Bang be just one phase in an infinite cycle? Share your thoughts in the comments below. If you enjoyed this discussion, don't forget to like, subscribe, and turn on notifications to stay updated with the latest discoveries about our universe. Thanks for watching, and we'll see you in the next one.